Welcome to Methamphetamine. Today we're gonna do the integral of psi of Lnx over Lnx from 0 to 1. And here, how will we integrate? Should we use the u sub? If you let u is equal to Lnx, you get psi u over u, and then du is equal to our 1 over x, right? But you get e to the u here, right? E to the u times psi u over u. I don't think it can be integrated, right? It will be very, very hard. And here is the deal. I don't like the side here. And here, we can change this side of something. Side x is equal to our imaginary number, e to the power of ix minus e to the power of negative ix over 2i. And it's the form of psi x in the imaginary version. You can check my other videos, and it is come from the Euler's formula. E to the power of ix, and then subtract e to the power of negative ix, you get that. And then here, if you put Lnx inside the x, you get e to the power of I Lnx minus e to the power of negative I Lnx over 2i. And here, because of the log property, you can just put the I in front of the Ln. So e and Ln, they will cancel each other out. So you get x to the power of I minus e to the power of, put negative I in front, you get e to the x to the power of negative I over 2i here. So let me just change it. Psi of Lnx from 0 to 1, and then x to the power of I minus e to the, not e, stop writing e right now. I like e so much, sorry. X power of I minus x power of negative I, and then 2i here, and then multiply by Lnx dx. And here, the Ln is so annoying. We can integrate, right? If we don't have an Ln, it will be very easy to integrate. And here's the deal. We're gonna use our Friedmann technique. I don't want this Ln. If we don't have an Ln here, it will be very easy to integrate, right? So we're gonna use our Friedmann technique. We let our I of t. You can choose other variable you like, but don't choose x and don't choose I or e. I despite this, I hate this variable so much because just don't. I and e, they have a meaning, and don't use pi here. So I of t, this is the Friedmann technique from 0 to 1, and then I would like to put a variable which called t here. X power of ti minus x power of negative I, 2i Lnx dx. And here we can do the derivative with respect to t here. So this is d dt, do a d dt on both sides, and then you get I prime of t here, and then do the derivative of the integral of this. You can just put the derivative inside, and this is called a partial derivative. Whenever you do a derivative of an integral with respect to something, you need to do this. Here's the variable of something, the integral inside with respect to t. I just leave that to you guys. So let me just write here. Here in the t row, L1x is just a constant, and 2i also they are the constants. Just write them. 2i Lnx and dx. And here's the deal. X power of ti, to differentiate this in our t row, and this like a constant, x is also a constant. To differentiate constant with to something, with to the t, you get, first you're gonna get the original back, and then talk Ln of x, and then multiply, because of the chain rule, you're gonna multiply by the derivative of ti, and then in our ti, and then I is just our constant, right? So multiply by I here, and then minus x power negative I, also a constant, so just don't care. Here you see L1x, I-L1x and I-L1x, they cancel each other out, so you can get the integral of, put a 1/2 in front of the integral, you get 1/2 of x power of ti dx. And to do this integral, you just get 1/2 multiply. First, you're gonna add 1 to the power, you get ti plus 1, right? X to the power of ti plus 1, just add 1 to the power divided by the new power, you will get that. And here, we're gonna put a 0 and 1. And 0 and 1, we're gonna put it inside x and not t. Be careful. Because this in our x row. Here, if we put 1 here, you get 1. 1 to the power of anything is just 1. So, the first part is 1/2 multiplied by 1 over ti plus 1. And then you're gonna subtract this. Put 0 of this, 0 to the power of something. Here, 0 to the power of I. Be careful, t cannot be equal to I here. First, if you put I here, you get a 0 to the power of, and then I times 1 is -1, and then you get 0, right? X, you put 0 and then to the power of 0 is undefined. And also, t cannot be equal to 1. No. T can also equal to 1. Just ignore it. Another domain here. Just put 0 inside, 0 to the power of something. To anything, it's just 0, just ignore. Because the original is just psi of L1x over, and this is converge. So just 0 to the power of anything is just 0, just minus 0. And then here, I prime of t, we're gonna right here, I prime of t, and then we're gonna do the derivative of dt on both sides. And here we're gonna do the integral of dt, just do the integral on both sides with respect to dt, and then I of t, the original, is equal to 1/2 is a constant, leave that, and then integrate it, you get L1 parentheses of ti plus 1, because ti, we are in the compass, and compass number, just don't ignore the absolute value here. And then because of chain rule, you're gonna multiply the chain rule. If you do the derivative of this, you will get, in our t row, I is a constant, so you can get I. So we're gonna divide by I to get rid of the I here. So we're gonna add a C1 here, add a constant, or C2. Let me just add C1 here. If you like, just C, that's okay. And here, what should we do next? And then our original, let me write here, original is 0 to 1, and then x power of I minus x to the power of negative I over 2I on x. This is just the same as that. This one is the same as that. But I of t, this I of t. So we should put t here. Ti. Here we can put a number. What should we put the inside? We can if we let t is equal to 1, this is just the original. We don't know how to do with this, right? If we put t is equal to 0 here, we don't know how to do integral of this. X to the power of this, you get 1, but this is also hard to do. So what about -1? If we put -1, you get x to the power of negative I, and this they cancel each other out, so you can get 0. 0 over that. In general, you just get 0. So let me just put -1 inside t, you get 1 over 2I Ln of Let me just write negative I plus 1 as 1 minus I plus C1 is equal to 0. So, ladies and gentlemen, C1 is just equal to 1 over 2I, put a negative, because we fold it on the right. Negative 1 over 2I ln of 1 minus I. So, don't you know this, we have a 1 here, right? So, let me just do it here. The integral of from 0 to 1 sine of ln x over ln x dx is equal to that I of t 1 over 2I ln of 1I. What? Let me just write this 1 plus I. Subtract our plus our C1 is just this minus 1 over 2I ln of 1 minus I. Here we're gonna factor out the 1 over 2I. And the ln of this, just dy. We can just dy by. Because of the law property, 1 plus I over 1 minus I. And this answer is a real number. You will see why. ln of 1 plus I over 1 minus I. Multiply by the conjugate to simplify. Multiply by 1 plus I at the same time. So 1 over 2I. Here, let me do some work. 1 minus I times 1 plus I is 1 minus I squared. 1 minus I, and then I squared is just negative 1. Minus negative 1, you will get 2. And then here, 1 plus I squared. Parentheses squared, you get 1 plus 2I, and then I squared is negative 1. 1 and 1, they are cancelled. Cancelled. So you get 2I over 2. And 2 and 2, they are cancel each other. And ladies and gentlemen, L1I, you can check my other video, and this is really famous. L1I is equal to pi over 2 I. And just don't add 2 and pi here. We just did one answers here. So here I and I, they are cancel each other out. So ladies and gentlemen, this integral is just pi over 4. And that's it.